Yeah, so as Dr. Lesher mentioned, we are the Millborn Seeds. We're doing an automatic bag cutting machine. My name is Hunter Walster. I'm Ryan Klein. I'm Matt Gerard. I'm Nicholas Christensen.
So in the past few years, Millborn has experienced 40% growth every year. And with that, there's been a big increase in automation of weighing, packaging, stacking, bags. One thing that hasn't changed though is the cutting, as seen here. And so with the device that we're designing, we're hoping to almost fully automate that. So our main goal is to increase the efficiency with which Millborn Seeds produces mixes by automating the cutting process. All right, so looking at some of the requirements that our sponsor gave us, he mainly wants to prove the concept for different designs that we want to go forward with. Right now, one person does about 4 bags a minute, and our goal is to hit 10 plus bags per minute, and maybe even higher if there's more people operating. We need to hit the basically 99.9% of seed needs to get out of the bag, so we can't have too much in the corner, because these can be like 50-pound bags, so even 0.1% is quite a bit, and it would cost them a lot of money over time. So it needs to be able to be run by one operator. If 2 can run it and it goes faster, that's great, but 1 operator is a requirement in case they don't have a lot of workers that day. They don't want to cut it down. Our maximum size that he gave us was about 20 by 20 area. He says we can go longer in one direction, we just can't go into the halls that they have set up. We need to make sure easy access for cleaning. That's very important, so otherwise then the downtime between different mixes of seed is going to be way too long. And it needs to be user friendly for the operator. So like on and off, their only control, and it needs to be ergonomic for bag loaders. So this is the state of the art. This is one of the things that we're looking to kind of go with. So you see they put it on the bottom and they'll convey it up. And then on that conveyor, there's 2 blades that will cut the bag into 3 pieces. And then when it gets over into the barrel, which is the design that we're currently looking at, it spins it, kind of tosses it around, dumps out the seed, and trying to empty the bag all the way. And it's pushed along by kind of like a corkscrew on there. On the top is a little filter that gets rid of the dust and kicks back the seed so they don't waste any of it. And then they kick out the bag to the bottom and drop it through an auger, which we're not going to go in that depth.
All right, so the first aspect of design we took into consideration was the plate types, as we have to open the bag before we put anything else open. So the designs we kind of wanted to talk about were single saw, multi-saw, band saw, and a hot wire. The hot wire was kind of eliminated right away as with the melting bags and that problem. But some of the other considerations we wanted to talk about with these blades were we have multiple different bag sizes, and we have multiple different bag types. So we have a paper, a poly, and a plastic bag. So we want to make sure that whatever blade type we choose is able to work for all of our bag types and sizes. So from that, we went through and made our decision that multi-saw would likely be our best, as it would split it into smaller pieces and make it so we can get those clumped up seeds out of the corners of bags. So the next design consideration was seed separation. So once this bag is split in half or cut open, we can just get that seed that's stuck in that bag out of it. So the first and the main one that you see here is a barrel that was also in the state of the art. So the idea is to rotate the bag around and let it just kind of jostle out all of those seeds. Some of the other ones we considered are a tooth conveyor, so we could kind of keep control of that bag as it goes through the system. A folding conveyor, so it kind of cuts the bottom and lets the seed fall out the bottom. But with that, we don't really have a lot of control over the seeds going over the corners of the bags. And then our last one here is the separation and vibration, where you kind of just let vibrations of a platform wiggle the seeds out. But we went with the barrel for our design. And the last thing, this was a very vital thing for Millborn, is they, in between pallets of different types of seeds, they want to clean out the seeds so there's not cross-contamination between different types of seeds. So as of now, they're using leaf blowers and other air nozzles in some of their other mixers and other machines. So this was kind of an important thing for them. But three main things we wanted to do were air nozzles, fans for manual blowout. We want to try to get away from this manual blowout. So air nozzles and fans were our kind of main idea, and for that was to put fans in the system to blow all the dust and seed into the main section where that barrel was, and then have compressor nozzles going out any of the spots where seeds could get bumped up, so that our dust system is suck all of that out the top.
So with that, we decided on a barrel as modeled on your right hand side, and trying to spec out just what exactly it'll take to spin this barrel. We were able to determine a mass moment of inertia through our SolidWorks model, as well as the mass of the barrel. So this barrel is approximately 6 feet in diameter and 8.5 feet in length, with a total mass of 400 pounds and a mass moment of inertia of nearly 900,000 pound mass inch squareds. So we are looking at a running angular velocity of 40 RPM. This will allow 2 bags to be within the barrel at the same time and within that 6-second window. We were looking for a startup time of approximately 5 seconds, as the maximum is going to be that starting torque, not the running torque. And from that, we were able to get a starting torque of around 160 foot-pounds. Incorporating the factor of safety 2 in there, we need around a 2.5 horsepower motor to be able to operate that barrel. This morning, we were able to go and test our cutting apparatus. So as you can see there, we slid a bag down a piece of wood with a saw blade through it, that we were able to kind of replicate the action in which our machine will operate. On your right hand side, you can see a bag that has 2 cuts in it. And we were actually pleasantly surprised, as this poly bag is likely going to be our biggest issue with fraying and whatnot. But after the cutting through, we found minimal fraying actually inside the seat, and all the fraying that was there was still firmly attached to that bag. So we were able to do a lengthwise cut as shown in the video, 2 horizontal cuts and a diagonal cut. And we found that diagonal cut to have the least amount of fraying. So we'd be likely trying to control that bag in a diagonal pattern through the blade. That has led us to our main model here, picture on the screen. So on the right hand side, there is a frame with a barrel inside. The seed will come up the conveyor, down slope through the blades into the barrel, to which it will disperse into the frame. Looking more closely, the cutting apparatus, we are going for a 2-blade design that'll have adjustable widths. So the blades will be able to move in and out to accommodate the different bag sizes. Within the barrel, it'll likely be driven similar to how a cement truck mixer works. A tire will rotate, and then the friction between the 2 will rotate the barrel itself. So kind of included with that torque calculation is the normal force required pushing that tire in that barrel. We figure it to be around 60 pounds. Within that barrel, there's a corkscrew that'll control the bag as it goes through this barrel. This bag will come in, it'll move through the barrel. There will be bars that flip it up in the air continuously as the corkscrew pushes it through the barrel, mounted in the frame. Here's a picture of the already existing conveyors. This is something we're having to deal with. Changes to this will be taking off the end section and increasing the height.
Here's a little look at our schedule. As Dr. Lesher mentioned, we didn't start this till October 20th. We just got our preliminary design review completed. And so moving forward, the big thing that we need to knock out before having a complete design in the second week of January is having a proof of concept ready of the barrel before we can decide, oh, it needs to be 4 feet long or whatever it is. We need to show that we have to spend X amount of time in the barrel before completely emptying seed.
All right, so looking at the budget, this is what we're currently working with. It's about a little under $20,000. On the left-hand side, those prices are all raw material. That's just based off our modeling that we've done. The conveyance is very cheap because we're gonna use the existing conveyors, that's just the structure for it to get it up where we need it. The other you see, that is for like paint, that is for controller, that's for wiring, it's for all the accessories that we have not put in yet. And then for labor hours, we're using $75 an hour for outsourcing, because a lot of this will not be made there, it's just a seed company, we'll have to get it outsourced, so that puts us around 18.5K, which is cheaper than our initial budget.
Is there any questions?
We might have not thought about this yet, so you just started, will there be problems with the increased angle with conveyor belt slipping of bags potentially, since you want to have somebody going there for a minute, or we'll have enough grip?
Yeah, so we are currently looking at maximizing that conveyor angle of 45 degrees. It is a rubberized conveyor, so there shouldn't be any issues with bags.
How large of a barrel are you doing? Sorry, how large of a barrel are you planning to go?
So the current design is a 6-foot diameter, about 8.5-foot long barrel. We're looking to reduce that down to likely a 4-foot diameter, just to be a little more cost effective. But that is to come when we do our barrel testing, like the
And as far as length, that kind of depends on how long a bag has to sit and spin in that barrel, so you can kind of find a length and a pitch of a longer hump.
Are you like worried about seed not coming out of the bags if it's cut on one side and lands like say where it stays in the corner of the bag when it's spinning around?
Yeah, so if you're talking about our testing photo, so with this, we weren't able to get a deep enough cut blade to get through that entire bag. Within the model, we plan to mount the blade above and then have it recessed into the slide, so we have full depth cuts.
So you're planning on cutting like the bag into 3 pieces, basically.
Yes.
Got it.
You go to your next slide. So, is there a reason why it's like so tall like that, or do you need it to be that tall, or like what's the reasoning behind like that?
So this black box on the bottom here, that's what they pro box. That's what they currently have to cut all their seat into. It stands about 5.5 feet tall. So we have to be able to get seats in there with enough clearance for forklifts. From this model, this cone shape will be reduced. We weren't sure as to what angle it will be, seat will need to slide into that pro box. It's modeled at 45 degrees. But from testing today, we were able to see that around 25 degrees it works. That'll shorten it by about 1.5 feet, and decreasing that barrel diameter will also increase it by about 1 foot. So it should lower it to the center of the barrel being about 13 feet off the ground.
You thought about cutting it on the ground and then taking the seat up to the box at all, so you wouldn't have to have the barrel?
Yeah, the problem with that is they're kind of a flimsy bag, so once you do cut it open, there's nothing holding that seat on the conveyor belt, so it would just kind of be spilling all over the place.
And if you're referring to, we cut the bag at ground level, dump the seat in something and auger it up or something like that. A concern with an auger is crushing of the seat. So they do currently use that as their mixer, but augering it multiple times would likely cause more damage.
So if crushing is a concern of theirs normally, are they also concerned about using saw blade to go through an entire bag of seed?
Yeah, so we were looking at that at testing today, and we did use a free-flowing seat today during testing, but we didn't see any damage to the seat at all as it moved around on that saw blade. The testing video shows about a 1-inch cut depth. We were able to get up to like a 2.5, 3-inch cut depth, and we still didn't see any issues with that.
So you guys mentioned that there's different bag sizes that Millborn uses and that your saw blades can adjust. Is that something that you would want to have to adjust manually, or is that something that the saw blade will do automatically depending on the bag size?
It'll likely be through a control system. For the cutting apparatus, we plan on putting a power screw between that are kind of connected to the center, so they'll be able to move in and out in sync.
So yeah, generally when they do this type of cutting, they'll cut like an entire pallet of the same thing. So you can kind of just set it for that bag, and then when you have to run your clean out, and then you can readjust your blades for the next pallet.
Are they relatively like the same height? Like, will you have to adjust like up and down for like depth and cuts of like different size, like height wise, or are they all kind of like the same?
Our blade, as of right now, should be big enough that it kind of just
One size fits all.
being oversized with this small bags, but big enough.
Size is the blade right now? 18 inches. That's a scary blade.
I know you guys were working with ways to drive that barrel, you come up with a wheel against the barrel, just maybe a minor modification. What if you replace one of the 4 roller supports with that wheel and motor? Because then it's automatically gonna pull down into that, probably have a little less tendency to try to push that wheel into the barrel. So just a suggestion.
If you're cutting the bags before they're in the barrel, and you're cutting them into 3 full sections, are you worried about losing seed before the seed gets into the barrel?
Yeah, so not pictured here. Surrounding that cutting apparatus, there'll be a slope section with 2 slits in it lengthwise, and another slope section underneath. So any of the seed that falls through that slope section will be caught and pushed into the barrel itself.
Talk a little bit more about what you're planning for,
Yeah, sure. So with the automatic clean out, like I said, they have to clean out each type of seed to minimize contamination. So one of the things that we thought of doing is adding compressor nozzles where there are any pinch points or any parts where seed could get packed and stuck into, and then have that system kind of be automated, so you hit one button on a controller and it pushes seed all the way through the system and either into our pro box for the seed or out the top if it's dust or other debris.
you talk about the dust collection. Maybe they didn't understand something.
Yeah, so with the dust collection, as seen in the state of art. So a lot of their other systems, because they're working with seed, there's a lot of dust that gets tossed into the air. And I think OSHA regulations, you can't have more than 1/8 of an inch of dust on surfaces. And so as you can see kind of above the barrel there, it's basically just a filtered vent that goes up top. That is kind of something that we could add on to our system once the rest of the design is kind of fitted.
Any other questions for this team?
All right, good job.